Here's another example of using the definition of derivative to calculate a derivative. So I've got this cubic function. Just happen to be able to see that it has intercepts here at 0 and at plus or minus the square root of 3. So here and there, this is a cubic function that looks like that. So just thinking in terms of what the derivative might look like, I see, I'm looking at slopes of tangent lines. So I see positive slopes for a while. Through here I see some negative slopes and then some positive slopes again. So the derivative is positive, then negative, then positive. And so it's not just going to be a linear function. It's going to be bending somewhat. So anyway, let's see what we get here. By definition, the derivative is the limit as h goes to 0 of f of x plus h minus f of x all divided by h. Right? This is just the definition. I haven't actually done anything yet. I now need to apply this to my function. Okay, so this is the limit as not as x goes to 0. Sorry, this is the limit as h goes to 0. This denominator going to 0. So here we go. Let's see if we get this right. The limit as h goes to 0 of okay, our function, this f of x right here, is x cubed minus 3x. I'm going to put that in parentheses and I'm subtracting it. What is f of x plus h? Well, f of x is saying, what do I do with x? I'm going to cube it, I'm going to multiply it by 3 and subtract. So I'm going to take the x plus h, I'm going to cube it, I'm going to multiply by 3 and subtract those two. So I've got x plus h cubed minus 3 times x plus h minus all of this stuff, all the f of x. And that whole thing is over h. Now, I've got to try to simplify that. I think what I'm going to do is I'm going to multiply this all out. I've got the limit as h goes to 0. The x plus h cubed is x cubed plus 3x squared h plus 3x h squared plus h cubed. How did I get that? Right? I've done some work on the side here. This is x plus h times x plus h times x plus h. That's what the x plus h cubed means. And you FOIL this out, and then you FOIL that out. And anyway, there's the result. Then I have minus 3 times x plus h, so that's minus 3x minus 3h. And then I have minus this stuff, so distributing that minus sign in, I've got minus x cubed plus 3x, the whole thing divided by h. Wow. Now, does anything nice happen? I hope so. Yeah, I think I see that I've got a plus x cubed and a minus x cubed. And I've got a minus 3x and a plus 3x. Those will go away. Minus 3h. No, I don't think anything else combines. However, I do notice that everything that's left has an h in it. Everything that's left has an h in it. So I'm going to take that h and factor it out. The limit as h goes to 0. That's a funny looking goes to. Well, goes to 0. So if I factor an h out from the first one there, there's a 3x squared right there. And then factoring an h out of this one, there's a 3x times h, because that was an h squared there. Factor an h out of that, you've got an h cubed. Well, I factored out, you got an h squared left. And then from this thing, there's a minus 3. And suddenly, my 0 over 0 situation has manifested itself. There's the factor of 0 on the top. There's the factor of 0 on the bottom. Cancel those out. Now I can actually take the limit. So I'm going to say as h goes to 0, well, there's no h's in there, so that's just 3x squared. This is 3x times 0. This is plus 0 squared, and then minus 3, for a grand total of 3x squared minus 3. Let's recap here. For f of x equaled x cubed minus 3x, f prime of x turned out to be 3x squared minus 3. Let me draw a picture again. Notice this was a cubic. That was my original function. And this is a parabola that's shifted downward. And it turns out it's shifted downward, like it looks like this. And the x-intercept here, where this crosses, is exactly where that has a horizontal tangent line, right? Because when this is slope 0, this derivative is 0, because the tangent line has a slope of 0, so the function is 0. Right here, the tangent line has a slope of 0, and so the derivative is 0. Right? Through this stretch down here, where the slope is negative, that's where this function is negative. When you're headed uphill, when you got positive slopes here, when you got positive slopes there, the derivative has positive y values, right? The y values of the derivative are telling you the slopes of the function you started with. Let me say that again. The y values of the derivative are telling you the slopes of the function that you started with. So where the slope is 0, the y value of the derivative is 0. Where the slope is positive, the y value of this derivative is positive. Anyway, there's an example with a cubic. It's got a little more, a little more work to it, but anyway, we end up with this function that's called the derivative, and we will do all sorts of things with derivatives throughout this quarter.